Hi, welcome back to Academic Market Insights. I'm Dr. Russell Rhodes, joined by, she's over there, Dr. Larissa Adamiec. This is part two, where Dr. A is going to whip out Excel and show us how to calculate a GARCH model. And I say part two, we divided it up a little bit, give you a break between all of the Excel work. It started out showing how to get the standard deviation and annualize that number for monthly returns and daily returns. And now you're going to dive back into the same spreadsheet. Yeah, is that you diving?
That is
And show us how to create a GARCH model. So fire away.
So GARCH really quickly is a general autoregressive conditional heteroscedasticity model. Say that 5 times fast. And it was produced by Professor Engel, and I know you know him. I was able to meet him once at a conference that you had put together, but it's a traditional econometrics model for predicting volatility. Okay, so what we did before was we looked at historical volatility. Now we want to have a model and say, what is the volatility tomorrow? Okay, so let's take a look. And if you're hoping that we do some optimization and we use a log likelihood function, you are in store for today. This is your lucky day, my friends.
So you chose FedEx.
I did.
Yeah, we had 10 stocks on the previous, and that's not what I thought you were going to choose, but go ahead. Sorry.
Well, Costco, and we'll go back to our, I think it's, nope.
That's test. Yeah, sorry.
So Costco, I know this is where we get in trouble for being chatty, but Costco was just lower on the volatility. So it's not as much, So FedEx, I thought would be a little more interesting.
It is. It is.
So this model has basically 2 factors. So we have our intercept, which is we're calling our omega. We're going to have the first coefficient alpha and the second coefficient beta. The alpha is going to be tied to returns, and our beta is going to be tied to yesterday's volatility. Okay. And I promise this will not be a deep investigation of what the model is and more on a how to apply. So I'm going to place some dummy variables in for right now so that we can at least see something. Otherwise, we're going to get lots of zeros and lots of divide by zeros. So let's put in 0, 1, 2, and I'm completely making these up. 5, 4, we'll go 2, 3. Now I'm going to change this from 5 to 3, 4. So favorite athletes, Walter Payton, Michael Jordan, got to throw that in there. So like everything we do, we are going to start with calculating returns. And this is daily data. So we are not using monthly because we are looking to predict tomorrow's volatility. It is much harder to predict next month's volatility. We're not going to try. Okay. So we're going to take today's minus yesterday divided by yesterday. Boom. Yay. We are then going to square this and multiply it by 252. Done. We are then going to lag it. So far, easy peasy, right? I'm very happy with these steps. Now we're going to start with our unconditional variance. And this is where we'll actually use variance or population of our returns. And I told you that our conditional variance, which is this HT plus 1, is really looking to predict the next volatility, the next day's volatility. We have to start with something. So we are going to start with this historical. So if you were to be doing this and you wanted to apply this to a trading model, we're going to use this entire sample for the optimization part. Now you can do this again for for trading purposes, but then you would input the new information, keep these coefficients the same, and then put in your new returns and your new volatility based on yesterday's volatility. Okay, so that's how you make the in sample versus out of sample. So let's go ahead and put in our unconditional volatility. So this is going to be the outlier. And now we're going to take and say omega. And remember, this is our intercept. Now we're going to add, oops. We're going to put in our first coefficient, which is our alpha, and we're going to multiply it by yesterday's returns. Oh, what did I do? And this is where keeping track of those little t's are very important. Next, we are going to have our final piece, which is the beta multiplied by yesterday's variance. So B 4 times yesterday's. Okay. Yay! So we have now all of our conditional variances. But remember, we put in dummy variables. So what we're going to use is a log likelihood function to minimize those squares. Okay, so we're taking this and now we're going to force those coefficients to create a graph with these two variables and the intercept, and we want the errors between them to be smaller. So we're going to use the log likelihood, and we're going to then maximize. We're going to sum up all of those and then maximize that value. Okay. And I should have put this on the spreadsheet, and it's in the notes for everybody. This is the log likelihood function. So this will be the natural log 1 divided by the square root of 2 times pi times our conditional variance times our exponent negative 0.5 times our returns squared divided by that conditional variance. Hopefully this works. Tink. There's no errors. Good. Okay. Move this over. Now I'm going to sum up all of our log likelihoods, and this is vital because this is what we're going to maximize, and we're going to use Solver for this. So if you've never used Solver before, you, my friends, are in for a fun treat. So go over to Data, Solver, and we are going to maximize this function by allowing for Solver to come up with the correct values for omega, alpha, and beta. And we are going to hit solve. It says okay. So now we have our function. So we are going to say that tomorrow's volatility will be 0.0045 plus 0.09164 times yesterday's return squared times 252, the day behind, plus the beta times yesterday's conditional variance. And that's how we would then predict the next day's volatility. So what we did was we've created this model and we have calculated those coefficients. And that is the general autoregressive conditional heteroscedasticity model used for predicting tomorrow's volatility. Now, this model has gone out of favor or vogue, so to speak. This was much more popular in the late 90s, early 2000s. Other modeling techniques have come along. There's models which put different weights on different things, like earlier information. Again, I would be very focused on taking a look at what the dispersion of returns to get a better sense for what time period you should be using. So again, there's a lot of art that goes into.
There's a lot of playing around that you definitely would want to do with the numbers. And I find it interesting that you say it's come out of vogue because with daily option expiration now, you'd think people would want to be predicting what the realized volatility may be the next day.
No, people are definitely still predicting volatility. This model,
There's
this model has just become out of vogue. So there's other models that are a little more popular, but this is one of the most standard introduction to predictive models.
Gotcha. Well, coolio. So now I've got to go figure out how to trade daily options using this thing.
And if you make money, don't tell us.
And now we're on summer break, I have all the time in the world to do that.
Yeah, that'll be a fun thing to do.
So coolio. All right. Well, you did good. So you can take us home because more people like videos when you ask them to than me.
Well,
with
that I'm going to say we thoroughly enjoyed doing this. Again, for students who are watching this, if you have any questions, please reach out to us. These are designed to help you. Not saying that you'll have a homework question on this, but you might.
You never know.
You might.
Yeah.
And if you like this, please hit like. And if you haven't already, please hit subscribe. My neighbor thinks we are rock stars because we have hundreds of subscribers at this moment.
We're in the low triple digits.
Yeah, absolutely. So with that, thank you so much for joining us.
Thank you very much.